I always knew that mathematics did something in my brain. I was sure that because of my eclectic or four-brain learning approach to mathematics, that I had practiced long before I coined this term. I had caused some transformation in the way my brain was wired. For others, math was just either a hard subject that was difficult to pass, or it was a cow for marks that would increase the average percentage in the finals. But for me, it was always something deeper. I knew that even though when I was studying basic arithmetics, algebra, geometry, trigonometry, and even later on calculus, something was happening in my brain. The way I thought was changing for the better. But until the time I decided to write this book, I did not delve into this matter. However, now that I have reached this particular section where I am discussing the effect of mathematics on the knowledge brain quadrant, or the green brain, or the upper left brain, as we have named this component of the brain in earlier chapters. I feel that I am ready to dissect the transformation that was caused by my four brain learning approach to mathematics. This section is not going to win me a PhD award because it is just a creative, novel idea that doesn't have either existing literature to back it up or empirical data from studies or surveys or even experiments. However, I still need to write this section because it has been so heavy in my heart throughout the last 40 years. Yet, this section is not the book on how math shapes human thinking. Yes, I would need to write this book one day, but for now, it is just a short section in an already fat, muscular, gigantic book on how to love your studies. So here I'm just setting my premise that what I'm going to talk about can indeed become very big and is enough to make a book, but at this stage I will not do so, and thus you as a reader should be content with just a snapshot of what this idea could be. In order for me to expose my idea, you will have to get familiar with the table below. The first column consists of the 13 components of mathematics that we discussed earlier. The first row consists of 8 different types of thinking that people engage in. You might be wondering what this means. Well, I'll explain using an analogy. Think of the process of thinking as a sport involving a ball. So, as soon as you play the ball, it is equivalent to saying that you have begun to think. However, there are many types of games that involves ball. Each of those games have different rules and objectives. There is football, which is played with the legs, basketball, which is played with the hands, hockey, which is played with a stick, cricket, whose objectives is very different from the earlier ball games. Then there is tennis with a very different objective. Now, table tennis and badminton look quite similar, but the balls that I used are different, and consequently the game is different. Similarly, process of thinking can be differentiated based on the objective and rules or processes involved. So this is where the 8 types of thinking arise from. That said, I have limited my list to only 8 types, but there could be more. I doubted that there could be less by merging 2 or more of the types listed, because they are significantly different from one another. However, future research will only tell. Next, the tick marks and the cross marks that you will see in the grids below signifies that that particular component of mathematics plays a role in that corresponding type of thinking. Where there is a tick and where there is a cross, it doesn't. So far, I think the table is quite simple. Now I will provide an exposition from the perspective of the different types of thinking. Let's start with the first type, which is the thinking for analytical and logical objective. In this ball game of the mind, our objective is to analyze the why, what, where, when, who, and how. It is also to understand the logic of events and phenomena. We could be analyzing why and the other 4 W's and 1 H on failure of a relationship to the behavior of the economy in a certain period of time. Although I'm just throwing darts in the blank, and what I'm going to say might raise more questions than they answer, I will still go ahead, because we are still in the hypothesis stage, and we have to start somewhere. As you can see in the diagram, to increase the analysis and logic type of thinking, 5 components of mathematics are highly conducive. They are numbers, the various operators, plus minus signs, the multiplication and divide operations, algebra. Now, my hypothesis is that once you know numbers, it's easier to analyze anything. You can count and assign numbers to the various events or phenomena that you are analyzing. Similarly, the concept of BODMAS and PEMDAS also work in the thinking process by providing us a sequence for analyzing various problems. Then the operators of plus, minus, multiplication, division help us to understand the effect of the various components of what we are studying or trying to analyze. Finally, algebra tells us that any problem is constituted of various components or variables that have a relationship with one another. Then if we are able to solve that equation, then we can logically deduce the answers from the analysis that we are doing. Of course, I'm not sure whether you also went through this transformative process in your intellectual life cycle. But for me, it almost occurred the way I have expounded here. Still now, when I think about how I use my logic and do analysis, I realize that the study of mathematics and those 5 components has helped me to think better in this particular domain. The next ball game is thinking for innovation and creativity. As you can see in the diagram, the mathematical component that I found most affecting this thinking type is fractions, ratios, and percentages. Then it's geometry, then algebra, and combinatorics. In total, those 4 components of mathematics dramatically help in innovation and creativity. I might seem like to forcefully make the connection here, but since it's a hypothesis that we have discussed, there is not much other option at this point. So the idea of fractions and percentages are very important in innovation because they help us put things into perspective. It's better to know how big or small is a thing compared to another when we want to create something new. Then geometry provides the various shapes and the properties of each shape that is very conducive to visualizing what we are thinking. I use it a lot by narrowing the number of causes, like even here 8 thinking types using shapes like rectangles, triangles, pentagrams, and so on. Then combinatorics tells us that there are many ways to do something. As for algebra, it's the same that I told earlier. It helps us find relationships between various components that we are thinking and come up with new values and thus new ideas. The third ball game is thinking for strategic problem solving, which is the best way to increase sales or to win a war by factoring the various threats and opportunities around us. So this is the type of thinking I'm talking about here. As you can see in the diagram, I think the component of exponentials is very useful here. It's important because it tells us that some opportunities and threats or strengths and weaknesses do not need to behave in a linear manner, and they can either increase exponentially or decrease exponentially. So this gives us a total new dimension for strategic thinking that differentiates the professional strategist from the amateur strategist. The other 4 components we have already discussed, and it's quite the same in the way they affect that particular thinking. Calculus is also affecting this strategic thinking. It is an extension of algebra, but because we had to learn about the rate of change and the effect of a phenomenon, it's also help us in strategy when we want to think about what will be the scope of our strategy. Will it impact us negatively or positively? And how fast will the change occur? The fourth type of thinking is for the big picture on the about seeing how the various components relate to one another and where it's coming from and where it's going. I understand that calculus, algebra, and geometry are very useful for this ball game for the same reasons that I talked earlier on. The action here is set theory because we need to find the relationships between lots of items, categorizing them into sets, and then any relationship between those sets, where they intersect and where they are non-inclusive or exclusive, is a contribution to the big picture thinking process. The next ball game is thinking for self-awareness and improvement. Here we are concerned about why we feel in a certain way and metacognition. It's also about what we want to improve, how and why. For that, the 3 components of math, namely numbers, algebra, and mental calculations, will prove very helpful. The effect of the first 2 components is the same as I have mentioned earlier on the thinking process. The new one is the mental calculation. Now, when you are able to make approximations, rounding off in our minds, then it becomes very useful when you are trying to be aware, like in counting your breathing, seeing your thoughts, observing where your feelings are coming from. It's also very useful when you want to improve. How long will it take? What sacrifices will I have to make? Trade-offs and so on. The sixth type of thinking is for empathy and ethics. Many times we need to be kind to others and try to understand others, get into the people's shoes. For that, fractions are very useful because it teaches us how to make proper comparisons. Set theory is very useful, where we can find common point between people we want to empathize with. The seventh type of thinking is for perception and intuition. Here we want to get in touch with our inner self, gut feeling. That's also thinking, For that, numbers are very useful, as well as the various operators like equal, greater than, smaller than. It's very useful because you can weigh the various feelings that various intuitions produce. So if a certain perception gives a heavier feeling than another one, it might be the one you want to pursue. Then mental calculations are useful in this type of thinking for the same reason as we discussed earlier, in making approximations and rounding off your feelings without having to exactly give a numerical value. Then geometry is always useful in intuition by providing a visual output for feelings that intuition and perception produce. They help us find an overall direction and shape of our intuition so that they can lead to something concrete like words and actual decisions. Finally, the eighth ball game is the thinking for specialized fields. It could be scientists thinking about quantum physics, or a cook thinking about a new dish. The mathematical process that would be used in this game could be geometry. In this way, we'll be able to present the various factors or elements that in our mind into shapes that are more manageable. Algebra is very useful because we want to find how various variables in our thinking in that particular specialized field relate to one another, and we could find various values based on that relationship. With calculus type of mathematical thinking, we would be able to know the rates and the effect. For example, the cook could be thinking at what rate the new dish will cook given the ingredients that he has put and the heat that he has applied. Finally, trigonometry, which is not other ball games of thinking, could be very useful in specialized thinking. It could provide the relationship between three components, three elements, three variables, three forces, everything that occurs in sets of three. It's amazing that lots of phenomena in the universe occur in sets of three. The Son, the Father, and the Holy Ghost would be a prime example that just comes in my mind right here. Also, trigonometry allows us to think of relationships between the cyclical nature of forces. That's a very powerful concept to have when you are thinking in a specialized field. In this way, I have provided exposition of the different ball games that I've called 8 types of thinking. Cannot say that this is a scientifically validated framework because it is just a hypothesis that I'm postulating here. I think that this is what I'm best at. I cannot deny my own life experiences and the wisdom I gain from them. Also, I cannot wait for a professor to give me the permission to write what I just wrote. I do not need the validation from an university to write something that my life and the various experiments that I've conducted through introspection and observation have validated. That said, I know that I'm asking a lot from you, my reader, but after reading this section, I want you to look inside yourself and your own journey of your mind and thinking processes. Ask yourself, haven't the various realms of mathematics that you studied in school, college, and university shaped the way you are thinking? It's a hard call, I know, but I made this inquiry in my own mind. It took me 40 years, and I basically wrote my findings in a few hundred words here. I hope that you will be inspired to do the introspection of your own intellectual journey like I did.